All right, good evening. It's 8 o'clock, so we're going to get started. So this is the final week of the class. And just a couple notes before we get started on the material. So with this being the final week, this coming Tuesday night at 11:59 p.m. Eastern Standard Time, that is the deadline to turn in any assignment, the current assignment, your final project, any previous assignment that you would like to turn in late. Tuesday night, 11:59 p.m. Eastern Standard Time is the last time that I can accept any kind of work to be turned into graded. There is no late submission allowed for the final project. And the reason being is that I have a very limited amount of time to finish all the grading and compile all your final grades and submit them to the university. So there will be no late assignment accepted. So please, please, please get them turned in on time. So I can get them graded and get your grades back to you. Okay. So this week's material is about objects. Really, it's the one of the fundamental concepts of object-oriented programming in general. Object-oriented programming isn't just in Java. There's a lot of languages that support object-oriented programming, but of course, Java is one of them. What I mean when I say object-oriented programming, now, of course, you can read in the class materials and you'll probably get a more structured dictionary type definition. But here's the definition I like to go with. Object-oriented programming is where you treat sections of your code or classes of your code and treat it as if it was an actual real-world object. For example, if you wanted to, do a programming project for a car lot, where you're going to buy and sell cars, right? That's actually the example we'll do this evening. But you can imagine you're writing software to manage a car dealership, right? So what are the actual real world objects associated with a car dealership? Well, there's a lot of things, but what we'll focus on is a car, for example. A car is an actual real world object. And so whenever we're programming out our car dealership this evening, we will take that physical concept of a real world object and, kind of make it into code. The code will, describe the car. It'll tell us the properties of the car, and it'll let us do actions with the car, all in our software. And we'll kind of see that build out as we go through our example this evening. So how do we make these objects? Well, first we have to make a class for the object. A class just basically is a description of the object. It tells you properties about the object, and you can describe actions you want to do with the object. So for our example, as I said, we're going to do a car dealership, and the first object really associated with a car dealership is the concept of a car. So let's make a new file, a new Java class. We'll call it car. And you see here, my IDE makes a new file called car.java, and it starts off with public class car. This is going to be our description of what a car is. Now, it will not contain, at least not initially, it is not going to be the specifics of it. For example, if we want to hold the description of the color of a car, our class here, it will just tell us that there is a color, but we're not going to assign a color, at least not yet, but we will get to that point. So let's think about the things that describe a car, the physical properties of a car. Well, first of all, you can have the year it was made. So in our definition of what a car is, one of the properties is what year it was built, right? So we will have the year, but of course we got to tell it what type it is. Is the year going to be a float, a double, a string? It makes sense for the year to be an integer, so we'll put int year. So that's one description of a car, what year it was made. What's another description of a car? Well, we can have a string that says what make it is. Toyota, Ford, Chevy, etc. We can have another string that tells us what model it is. And that could be like a Jeep. Well, the Jeep is the make, but it can be like a Wrangler. The make and model could be like a Chevy Cruze. The make and model could be like a Ford Pinto, right? For the make and the model. But these are descriptions about what our car is. Let's do a couple more. We'll do the color. We'll just have a string for the color. Of course, you know the color: red, green, silver, black, white, whatever. And what's one more description of a car? Let's see. Year, make, model, color, how many miles it has on it, right? That is a description of a car. So we'll put, and it'll just be an integer. Yeah, you could have a float, 3.2 miles or something like that. Sure. But for simplicity, I'm just going to make it an integer. So these are different descriptions of what a car is. These are what we call the member variables, meaning they are variables inside of this car class. And these are, you think of them like the adjectives of what a car is, the description of what a car is. Now, let's think about what are the actions you can do with a car. Okay, let's just list out some actions. We can drive a car. We can fill up the gas tank on a car. We can buy a car. We can sell a car. What else can we do? Drive it, fill it up, buy it, sell it. We can wash our car, right? Let's just say those are some different actions that we can do with our car. Okay. So with these nouns or adjectives really that describe a car, these are just variables. But these are more like verbs. If you drive a car, that's more like a verb. That's an action you can do with a car. You can fill up the gas tank. That's an action you're taking. Buy, sell, and wash. Those are all actions that you're taking. You're actually doing something with the car, not just describing the car. This describes the car. These are the actions you can do with a car. So when we're talking about the actions, the things we can do with a car, those are going to be more like methods. So for drive, let's make a method called drive, like that. And we'll fill out the details here shortly. For fill up the gas tank, we'll just call it that, fill up gas tank. That's another method. To buy it, we could buy our car. These are all actions. Like I said, we'll go through and fill out the details. We could sell the car. We could wash the car. And one more I want to add on here. You can also use it to compute information about your car. Okay. So these are all the description of the car. These are a bunch of actions you can do with the car. And you can also have it do computations for you. For example, let's say we want to figure out how much is the property taxes on our car. Let's make a method that will compute what is the property tax. So we'll have it return a float because we're going to do some money computation, and it'll return, whatever the cost of the property taxes. And I'm just going to call it compute. I'm just going to call it compute tax. And in here, we'll actually do that. Now, there's one more thing we need to do whenever we have these class. So, as I said, this is a car class. It is the code equivalent of a real world object that is a car. This is the description of the car. These are actions we can do with a car. We're just going to do some kind of computation with the car. One other thing we have to do is we have to set the initial values of the car. And we do that with a special function called a constructor. And it looks like this. You call it the same exact name as the class. You see, we have a public class car, and the constructor it has the same name. There's car, there's car. And what happens is this method will automatically get called by Java whenever you make a new car, which we will get to here in a minute. But just know this code is automatically ran whenever you make a new instance of a car. And this is a good place to where you want to set up your initial values. So we'll do it like this. We'll say the make is just blank right now. The year will be 0. I'm just setting up some sane initial values, which really is just a bunch of blank strings and 0 integers, right? So let's just say that is my initial values. And whenever I say this dot, I'm referring to these variables right here. So when I say this dot year, I'm talking about this variable. This dot make is this variable, and so on and so forth. So what I can do is, if down here I do this dot year, it is referring to this same variable. This is referring to this variable, and this right here is also referring to this variable. So it's a way that you can share the variables between each of these different methods. Okay, so like I said, this constructor gets automatically called when you make a new instance of class. So this code gets ran. I'm just setting some initial sane values, just making everything 0 basically. Okay, so now when we drive a car, what do we want to do? Well, whenever you drive a car, it increases the number of miles on the car, right? So if we drive the car, maybe we drive it 10 miles. Okay. You see how that kind of makes sense? Is this miles is part of the description of the car. And now, whenever we do this action, whenever we drive the car, we're going to increase the miles by 10 because we're just saying, hey, we're going to drive 10 miles. And now this updates the description of the car. So now, initially miles is 0, but if we drive it, the miles is now going to be 10. If we drive it 2 times, the miles will be 20. If we drive it 3 times, the miles will be 30. But we don't always just drive 10 miles. So we need a way to specify how many miles we drove the car. And we could do that with a parameter here. Miles driven. Again, the making methods and the parameters and stuff shouldn't be new. That's stuff from 1 and 2 weeks ago. So here we just changed our drive method that it's going to take how many ever miles we drove as a parameter. So now when we update our miles, instead of increasing by 10, we're going to increase it by how many ever miles we drove. How many ever miles we drove. All right. So that seems pretty good for drive. We just increase the number of miles. All right. So if we fill up the gas tank, well, let's make another variable that says how much gas it has in it, right? We'll just call it gas. Let's update this. Starts off to be 0. So let's say if we fill up the gas tank, let's say we put some gas in the tank. Again, we could just do this. Maybe we put 10 gallons of gas in it. Well, let's also put a parameter here that says how much gas we put in it. Let's call this amount. There we go. So now if we fill up the gas tank, we're going to tell it how much gas we put in it, and then we just increase the amount of gas by that much. Again, this gas is referring to this right here, how much gas we have in it. All right. Now, if we buy and sell a car, I'm not going to worry about these. Actually, let's just delete those off of there. Don't want to make this too overly complicated or too long. All right. Let's just say we want to wash the car. Well, let's have one more variable that describes our car. We'll make it a Boolean, and it'll determine whether it's dirty or not. If our car is dirty. So let's set the initial value. Initially, it will be dirty. So now when we wash our car, instead of our car being dirty, our car is now going to be clean. So we'll say dirty is false. It's clean now because we washed it. And let's go back up here to our drive. Let's say whenever we drive our car, we make it dirty. All right, drive wash. And then compute tax. Don't worry, we'll go all the way back through these. So compute tax, each year you have to pay property tax on your vehicle. So let's compute what is the amount of property tax we owe on our vehicle. I don't know. I don't know the real world formulas for computing that. So let's just make up our own. We'll say the amount is equal to the num years old, meaning, how many ever years old it is, times, I don't know, 10. I'm just making up some kind of formula for computing the property tax. All right. So as a car gets older, it computes as more tax. I think that's actually counterintuitive to what they actually do. But let's just say that's what our formula is. I'm not a tax expert. Okay. So we need to compute that amount. The amount is the number of years old. Well, it's 2023 now, minus the year it was built. This dot year is, the year the car was built. So if it was built in 2023, then, that's going to be 0. If it was built in 2022, that's going to be 1. And then we'll just multiply it by 10. And for some reason, that's how many dollars you owe in property tax. All right, so let's look back through our car one more time. So we have this description of a car. Well, first we have a class called car, and this is a description of a car. A car has a year, has a make, a model, has a color, has the number of miles on it, has how much gas is in it, and if it's a dirty car or not, true or false. In our constructor, this is a special function. It has the same name as the class. And here's where we want to set our initial values. What are all these things initially equal to? And right now, and we're actually going to get to modify this, but right now we're just going to say, everything is basically 0, a blank string, and true. That's the initial values. All right. Now, all of these are actions. These are things we can do with a car. So when we do an action with a car, we're actually changing what the description is. So when we drive a car and we drove it this many miles, then we change how many miles the car has on it. So the description of miles increases by how many miles we drove. We change the description of the car. And I'm just making up that we made the car dirty whenever we drove it. Actually, let's update our gas too, right? So if we drive it, our gas will decrease. See, miles driven divided by 2, maybe. That's really bad gas mileage. That's like 2 miles per gallon or something, but not important. So when we do this action with our car, we're updating the internal state. We're updating this description. The miles go up, the gas goes down, and we made our car dirty. When we do this action, when we fill up the gas tank, we're just adding more gas to our car. We're updating how much gas is in it. When we wash our car, when we do this action, then the car is no longer dirty. So the dirty is now false. It's not dirty anymore. And then this one isn't really an action, but we are using the car to compute something about itself. And here we're just computing how much tax we owe on the car. And this is the formula I'm using. It's probably not a really good tax formula, but it's the one I'm using. So compute tax. So now how do we use this car? So this just creates the description of a car. This is, the physical description of a car, and these are all the things that we can do with a car. But now we need to actually do it, right? So this is just a generic car. So let's go here, and here is how we actually make what we call an instance of the car. We say the class name, which is car. Then we need to make a variable name, which is called my car. We're not done yet, but what we're doing here is saying that's the type and that's the variable name. That's really no different than if we say int y, right? Int is the type and y is the variable name. Here, car is the type and my car is the variable name. This car can be a type because we made it here in this other file. We made a class car, so now car can be a type that you use, just like we have here. This car is the type, my car is the variable name. But when you have a complex object like this, if you just have int y equals 0 or something, that works just fine. That's no problem for your very basic types like integers and floats and strings and things like that. But when you have these objects, it's a little more complicated. So you have to say the type car, variable name my car. You have to put equals new car, like that. That will create a new car. So I have this variable my car, and I can do any of these things I want to do with my car. My car isn't what we call an instance of the car. So with the my car, I can drive it. I can fill up its gas tank. I can wash it. I can compute how much tax it has on it. So actually, let's use it to compute the tax. And we do that like this. We use the variable name, which is my car. We put a dot, and then we put what we're trying to do, which action. Here, I want to compute the tax. And it's a float because we're just saying it's money. So the cost is equal to that. And now let's print out the cost. System.out, print ln. I'm just going to print it like that. I'm not making it fancy. So what I'm doing is I'm making a new instance of my car. I'm using its method, compute tax. Again, my car is the variable name. Then we put a dot and the method name we want to use. Here we're using compute tax, which means whenever I run this line of code, it's actually going to execute this function right here, this compute tax function. And what does it do? It computes some money and it returns to me the money. All right. And then, so we're going to compute the tax and then we're just going to print it out. Let's run it and see what happens. There we go. And it prints out 20,230. Does that make sense? Actually, it does because, I said these were the initial values for my car. So the year is 0. And so we see when we compute the tax, 2023 minus 0 is 2023. Then we multiply it by 10, and that's how much tax it is. So that ends up being right. So actually, instead of being made in 2023 or made in 0, let's say my initial value is 2020. Now, if we run it, now we owe 30. Now, does that make sense? So whenever I look at my compute tax, the year is 2020. So 2023 minus 2020 is 3. And then 3 times 10 is 30. So yeah, we got the right answer. So let's change this year back to 0. So, here in our car, this is what all the initial descriptions are, right? Well, actually no car, has all of this type of information, right? So we can change the specifics for each car. We can say my car, and we can also access as variables. Asterisk here, I put a big asterisk here. For this basic level of Java, this is fine. Once you get to higher level Java classes, you do want to disallow the direct access of these variables from outside the class. So here in my main, I am outside of the car class, but I'm directly accessing the variable. That's okay for this class. In your higher levels of Java, they'll talk about why not to do that, and the way you should approach it instead. But for our simple examples, we're going to do it. So we can say my car, let's say it's a 1970, it's some kind of classic, actually, a 1965, right? We can say my car, the make is a Ford. The model is a Mustang. It's a nice car. What else do we have? We have the year, the make, model, color, miles, gas. The color will be red. The miles will be 20,000. And dirty is false because you better keep that kind of car clean. All right. So here we're setting what our initial values are. I said whenever we do the new car, that is what calls this constructor setting everything in kind of blank values. But now we can change them to explicitly what we want. All right. So one other thing we can do, we'll have to do a little bit more work here in a second. Let's say we want to print out what the car is. Maybe this will give us a good description of the car. And this will help me explain the kind of next concept. So here we can just use our system.out.println and we can print out my car. Now this isn't going to work exactly like you might think it would, but we'll fix it. We run it. Yeah, we kind of get that printed out, and that may not make too much sense, and that's fine. What it means is just saying there's a car variable, and this is actually the address in your memory, in your computer memory, where that object is being stored at. That's kind of what that means. But that's not what we want when we print out a car. We probably want it to, tell us all this information about it, right? So what we can do, we can add another method here, and this is kind of a Java exclusive type thing. And we can call it toString, like this right here. If you put this method in any class, really, then whenever you print out that class, whenever you print it out, and here we're printing my car, this is the function that will get called. And so you just need to construct some kind of string and return it. For our examples, we're just going to return the year plus a space plus the make, a space plus the model. We're just going to say the year, a space, the make, a space, and the model. So whenever this car gets printed, I'm just going to return this string, and then that's what's going to be printed here. So now let's run it, and we'll get something better looking. There you go. So this car is a 1965 Ford Mustang. Let's actually print out the rest of the stuff. So make, model. What else do we have? We have a make, model, color, miles, gas, and dirty. So plus the color, space, plus the miles, gas, I think, and dirty, I think that's all of it. So now when we run it and we print it out, so we're getting it. It's a 1965 Ford Mustang. The color is red. It has 20,000 miles on it. It has no gas in it, and dirty is false. You see that kind of lines up with what we're doing here. So this way, if we print out this car, we can kind of see what the status of the car is. So let's do one of the other actions with the car and then see kind of what the result is. So let's come up here. Let's do the drive action. Let's drive our car. All right. So we're going to set up the initial values for the car. We'll print it out. Then we're going to drive my car dot.drive. We need to tell it how many miles we drove. Let's just say we drove 120 miles. Now let's print out the car again to see how it changes. Now we run it. There you go. So this is before you drove it. This is after we drove it, right? So before we drove it, 1965 Ford Mustang red, that stays the same. We didn't change anything about the make, model, or the color whenever we drove it. However, the miles, they were 20,000 because that's what we said. And then we said we drove it 120, so we can see the miles did increase by 120. Now the gas tank was 0, and this doesn't make too much sense in real life. But now that we drove it, we have minus 60 gallons of gas. Actually, let's give it a little bit more miles per gallon. Let's say it gets 20 miles per gallon. A little bit more realistic, right? Let's run it. There we go. So we still started out with 0 gallons, and we went to minus 6 gallons. And we still started with 20,000 miles, and we went up to 2120. Again, and our dirty went from false to true. And why did all that happen is because we said our variable dot, this drive action, this is how many miles we drove. So what happens? This code gets executed. We increase our miles by 120. We decrease our gas by this much. And then we say the car is dirty now. All right. So that's it. So now miles, put our gas in there. So let's say we start off with 30 gallons of gas. Maybe it's got a big gas tank. Now when we run it, here you go. We started off with 38 gallons of gas. Now we're down to 24 gallons of gas because we drove this many miles, and that was the gas mileage. All right. So now our car is dirty. Let's wash our car. We can have my car dot wash it, and now we'll print it out again. Now when we run it, here's our car initially. This many miles gas, and it's not dirty. We drove it, so the miles went up 120. The gas went down by a little bit, and it's true now that it's dirty. And now we wash it, and the miles didn't change, the gas didn't change, but it's no longer dirty. The dirty is false. So this is how we can make an instance of the car, and then we can start doing things with the car. We can drive it, we can wash it, we can print it out so we can see what all the values are that make up a car. All right. So the one more thing we'll cover is, okay, what if there's 2 cars? How do we do this for 2 cars? And actually, it's pretty easy. Let's take out all these things. So this is, one car. This is called my car, and this is setting up all the description for that car. Well, we can have another car. There we go. So we have this car, and this is describing that car. Now we can make a variable called another car. Again, there's the type name. The type is a car. There's the variable name. And then we have to do the equals new car because it's an object. Now with another car, we can set up the values. It's a 2020. The make is a Jeep. Oops. Another car, the model is a Renegade. Another model, the color is silver. The miles is, let's say it has 30,000 miles on it. There's car, the gas, maybe it has 10 gallons of gas in it. And the dirty is true. So that's the initial state of this other car. So let's print both of these out and see the difference. When we have, first we'll print out my car, and then we'll print out another car. What I want to show you here is that even though they have the same type car, they are indeed different objects. This is the variable my car, this is the variable another car. So This car is completely separate from this one. So even though I set some values for this car, in no way does it affect this car. They do not affect each other. Oops. Not my car dirty. Another car dirty. There you go. They don't affect each other. So they are really based on this car class, this car type, which again, this is the description. That's the special method of the constructor, and then all of these actions we can do. But this is just kind of like a framework or a description of it. Here, we're setting the actual values of that description with my car and another car. So you see, this is my car, this is another car. Put a little label in front of them. So that when we print them out, we know which one we're looking at. All that's doing is just adding a little label to the front. There you go. That's just saying my car is that one and another car is that one. So now if we would, drive another car 10 miles, let's print them both out. We'll see that we change the description of another car, but it does not affect the my car variable. Let's run it. There we go. So here is my car and another car initially. Now we drove another car, but you see my car did not change because that's not the one we drove. The another car is the one that did change. 30,000 miles to 30,010. Gallons of gas, it actually stayed the same because I'm not using floats, I'm using integers. So you probably actually used about half a tank of gas, but I decided not to use floats. If we would drive it further, let's say we drive it 100 miles, we'll see the gas change. There you go. The gas went from 10 to 5 because we used like more gas. And that's about all there is to objects. Now maybe you're thinking, what are the use for these are? I mean, the use is that this car is kind of like a centralized container for everything to do with the car. The description of the car and all the different actions you can do with the car. Helps break your program up into smaller pieces. Instead of having all of this stuff just directly in your main, you're breaking up this idea of a car into a completely separate class and a separate file. And so it actually makes it easier for you to work like in a team where you can split the work. You could have one person working on main, another person working on car. We could have another class called car dealership, which, on there, maybe you buy cars or you sell cars or you trade cars or a bunch of other things. You can imagine that you have another class that allows you to do all those things. But for the very first level of Java, this is about as deep into classes and instances that we really need to worry about going today. So that's pretty much it. Your final assignment is out there. As I mentioned at the beginning, please get it turned in on time because I will not be able to accept it late. So if you have any questions, I'll go ahead and take them now. All right, you got your message, Jason? No problem. All right, go ahead and wrap it up. I'll get this video, and actually, I'll go ahead and post a video from one of the other semesters as well. Maybe there's some more information on there that may help you guys out, but I'll go ahead and get both these videos posted up here shortly. Again, if you have any questions or any issues, please email me directly. I get notifications on those. I can usually respond incredibly quickly. But the class is wrapping up. I want to make sure everyone has learned something and gets everything in on time and gets in the best work that they can do so their grade will reflect it. So have a good evening and let me know if you need anything.